Good morning. In today's video, we're going to be talking about sequence and series, and I'm going to be talking more on series today because I've talked more on sequences. And the series we're going to be talking about is geometry progression. So, without wasting much of our time, what is a geometry progression? Instead of any sequence that goes like this: the first one A, the second one AP, third one AP squared, third one AP cube, to APN. This is what a geometric progression. And how is the geometric progression formed? It is formed by what multiply the first term with a constant term to get the second term. For example, we have our first term here to be A. For us to get the second term, we'll multiply the first term by a common term, which is what? Let's say that our common term is P. Common term is equal to P. Let's say that our common term is what? Is P. And to get the second term of a geometric progression, we'll multiply the first one by the common term P to get what? AP. And to get the third term of a geometric progression, we'll multiply the second term by the common term P to get what? AP squared. And that is how it goes. So now I say that any sequence that follows this pattern is called a geometric progression or an exponential what? Sequence. So now let's go back to series of a geometric progression. What is a series? It's just the sum of what? The terms in the sequence, the sum of all the terms in the sequence you want to work with. So now let's say we want to find the sum of the first term of a geometric progression that goes this way. And the sum of the first term is what? A, because A plus nothing is what? A. A plus nothing is what? A. And since we are looking for the sum of the first term in this sequence is A. And sum of A is what? Is A. So we go back to the sum of what? The first two terms. And what are the first two terms in this sequence? It is A and AP. So now their sum is what? A plus AP. We'll go back to the sum of the first three terms. It is what? A plus AP squared. So down to what? Sn. I want to stop at n. If you wish to stop at m, no problem. If you wish to stop at p, no problem. Anywhere you wish to stop, no problem. So this is what? A plus AP squared plus plus APn minus 1. Now you might be confused on why it said you might ask why didn't I stop at AP raised to n. Now remember, for us to get this one, this term here A is behind this one, so we multiply this A. We multiply this A to get what? This one, to get AP. We multiply this one with P to get this one, AP squared. So that means that when we multiply this one with P again, we are going to have what? AP raised to the power n. Let's check it out. This is AP n minus 1. We will multiply this with P. We have what? AP n minus 1 times P to be what? AP n minus 1 plus 1 to be AP raised to the power n. Alright, so now we see that. So this is the term. For example, now this P raised to the power n minus 1 is this term. Is no, it's not this term. This A is this term. Now if P is 4 and we are asked to find the first 5 terms, now it simply means that this n minus 1 is what? 5 minus 1 to give us what? 4. And P raised to the power 4 multiplied by A is going to give us what? The fifth term, T5. Meaning that when we sum all S1 plus S2 plus, when we sum the first 5 terms, which is A1 plus A2 plus A3 plus A4 plus A5, we get what? S5. What I'm trying to explain is why I wrote n minus 1 here, and this is the term. When you do this now, you get what? The nth term. So let's take for example now, they say that the first term is 3 and our common ratio is 2. A is equals to 3 and our constant, the constant, or the one I call constant, or what is popularly known as ratio, common ratio, or some know it as factor. You say it is what, let's say ratio is equals to what, 2, or let's say 3. And we are asked to find the sum of the first 4 terms. Since we know that the first term is what, 3, the second term is going to be what, 3 times 3, the third term is going to be 3 times 3 times 3, the next one is going to be what, 3 times 3 times 3 times 3. So now S4 now is going to be what, 3 plus 9 plus 27 plus 81. So now let's say S4 now is going to be what? This is 90 plus 31, 20. Now this one is pretty easy, right? Yes. So now I want you to think, what if we are asked to find the first 50 numbers, the first 50 terms, or the first 20, even the first 10 terms? Will you continue doing this way? There is no time. No. That is why there is a formula we use to do this, and that is mainly what I want to achieve in this video. That's mainly what I want to achieve in this video. So when I will want to derive the formula, we say S1 is equal to A, S2 is equal to A plus AP, down till Sn is equal to what? A plus AP plus AP square plus AP cube plus dot 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 plus AP n minus 1. Now I want to find sum to what? To n. Sum to n. Sum to n. So now we multiply this one by what? P. We multiply this one by P. Let's check what it's going to give us. And I'll say AP plus AP2 plus AP cube plus AP4 plus dot 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 plus AP n minus 1. Okay, let me start from n minus 2 plus AP n minus 1 plus AP n. Now I want to tell you something again. Within this 3 dots, there are many numbers that are in there, uncountable numbers. So what we do is what? We take the ones we need and discard the ones we don't need. For example, now here, we do not see A raised to the power 3. We do not see A3, A cube. We will not see A raised to the power 4 here, but we saw it here. It's because it is inside these 3 dots, and here also, we will not see AN here. It is inside, also inside these dots. So what we'll now check, we'll now do something. We say, what if we subtract this from this? Say Sn minus P Sn. Now this is going to give us A plus AP plus AP square plus AP cube plus dot 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 plus AP n minus 2 plus AP n minus 1. Now minus AP square minus AP cube minus AP raised to the power 4 minus dot 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 minus AP n minus 2 minus AP n minus 1 minus AP n. So now we carry out these operations. We now see that this one will quickly take care of this one, this one will quickly take care of this one, this one will quickly take care of this one, this one will quickly take care of this one, and this one will quickly take care of this one. So what do we have left? To see that we have A minus AP raised to the power 4 minus dot 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 minus what? AP raised to the power n equal to Sn minus Psn. So now that is that. So now we now say, let us just remove these negative signs. You see that p raised to the power n is bigger, far bigger than what p raised to the power 4, because we don't know what n is. N can be a very big number, but I know that after counting p raised to the power 4 before you go to p raised to the power what? N. So since it is bigger than this, we discard this one and use this very one. So we now say that is a minus what? A p raised to the power n is equals to Sn minus p Sn. So now, since we need them sum to n, we don't need them p sum to anything, we now say that Sn bracket 1 minus p is equal to, I'll now say a bracket 1 minus what? P raised to the power n again. Since what we are looking for is the sum, the formula for the sum, we now say this is equal to what? Sn is equal to 1 minus p raised to the power n over what? 1 minus what? P, and that is what? The answer. A bracket 1 minus p raised to the power n, that is dividing both sides by what? 1 minus p, and that is it. So, but there's another thing I want us to do. I clean this place. I say, what if we subtract this from this? We say p Sn minus Sn, this is going to be, okay, let me do it here. This subtracting this, so this one will take care of this, will take care of this. Don't worry, let me write it out. We say ap minus ap plus ap squared plus ap cubed plus ap cubed plus ap raised to the power 4 plus dot 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 plus ap raised to the power n minus 2 plus ap raised to the power n minus 1 plus ap raised to the power n minus a minus ap minus ap square minus ap cube minus dot 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 minus ap n minus 2 minus ap n minus 1. So now we see this and this will be off, 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 this and this will be off. So what again do we have? All we have here now is ap raised to the power 4 plus dot 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 plus ap raised to the power n minus a is equal to, this is p Sn minus Sn. So what again? Since we are looking for sum to n, we bring out our Sn to the p minus 1 to be equal to, and see a raised to the power n, ap raised to the power n is bigger than this, so now say ap raised to the power n minus a. We'll discard this one because we don't need it. So now the next thing we are going to do is this. We say Sn p minus 1 is equals to a pn minus 1. So now this is going to say, give us that Sn, this is going to give us that Sn is equal to a p minus p raised to the power n minus 1 all over what? P minus 1. So we'll now see the two formulas here. Sum to n is this, sum to n is this. So there's some kind of contradictions, but I don't have enough proofs now. But there are some questions you use this to solve, you get them correct. When you use this, you use this, you get them correct, you use this, you get them correct. But there are ones you use this, you get correct, you use it, you not get them correct. And so once you use this, you get them correct, but when you use it, you not get them correct. So it just depends on, right now I am on the state of try and failure. If I try this one, it works, fine. If I try this one, it works, fine. But if I try any of them, it doesn't work, I'll try the next one. And at this juncture, I wish to stop. If you have any question, put it down in the comment box. If you have any correction to give, I am open to corrections. Do have a nice day. I am Timothy. Thank you.